All right, here we go. First video of 2013. I know you guys are pumped. Probably not as pumped as me. You can see we're going to Chapter 9. We're going to do 3 sections, 9.1 to 9.3, and then we'll be getting ready for midterms. Okay, what you see here first is we're going to look at sequences and series. Kind of a definition, I guess, we could use for sequences. We're going to use this a lot. I'm just going to put A sub 1, A sub 2, A sub 3. Because we're going to use the A when we use formulas. And basically a sequence it's just a pattern of numbers. A lot of this is patterns. And this is good that we're going over this because the SAT really goes over a lot of patterns. Series, now what a series is, it's the sum of a sequence. I always kind of look at the example of, if you think of the World Series, well, it's the sum of all the games won. You know, whoever wins 4 games wins the World Series. That's how I kind of think of series. It's basically you have all the numbers that are in a pattern, but you just add them up. We'll get into that. The series is what we'll get into in class tomorrow. What we'll really look at is sequence. And when you look at any sequence or pattern of numbers, you usually can represent it with a formula. Now, speaking of formulas, we're going to do number 1 right now. The formula is given to us. Now, this A sub n, that's the formula. If you make n equal 1, now it says find the first 4 terms. If I make n equal 1, then it gives me A sub 1, which is the first term in the sequence. That's what all of this means. You know, A sub 1, this means it's the first term. A sub 2 is the second term in the sequence. A sub 3 is the third term in the sequence, and so on and so forth. So if I just plug n equals 1 in here, I have 3 times 1 minus 2. So it gives me, what, 3 minus 2, which is 1. So that's the first term. Right, I make n equals 2. So that gives me A sub 2, which is the second term. And I just do 3 times 2 minus 2. So let's see, for that we get 6 minus 2, which is 4. Okay, I do n equals 3, right, which is A sub 3. And it's real easy. I'm just kind of plugging and chugging along. So 3 times 3 is 9. 9 minus 2 is 7. Now, this actually is called an arithmetic sequence. And this we're going to get into in a couple days. It's actually section 9.2. If you look, there's a pattern. You could call it arithmetic. I also like to call it linear because it always goes up by the same number. So if you plug in n equals 4, you know you're going to get 10. It goes up by 3 each time because of this 3. It's kind of like your slope. So if you plugged in n equals 4, I'll squeeze this in. It's 3 times 4 minus 2. And 12 minus 2 is 10. So real easy. So 1, 4, 7, 10, they're the first 4 terms of the sequences. Okay, I'm going to skip to number 3, do a little bit of a harder one here. I want to get the first 5 terms of this sequence. And this is the formula that's given to me. Okay, this negative 1 to the n, and it's over 2 times n minus 1. So I'll try to squeeze this in. I'm going to do n equals 1. Okay, when I do that, it's negative 1 to the first power. And that's over 2 times 1 minus 1. So negative 1 to the first, that's what? Negative 1. And 2 times 1 minus 1 is 1. So that really is just negative 1. Okay, I do n equals 2. And we're going to have negative 1 squared over 2 times 2 minus 1. Now, negative 1 squared is positive 1. And the bottom, 2 times 2 is 4. 4 minus 1 is 3. So we get 1/3. I'm going to circle these. Now, I'm going to just do a couple, and then we're going to see the pattern and kind of cheat and get the other ones by coming up with the pattern. Okay, I'm going to do n equals 3. When I do that, I have negative 1 cubed, and that's over 2 times 3 minus 1. Now, negative 1 cubed is negative 1 up top, and then 2 times 3 is 6. 6 minus 1 is 5. All right, now, you should be able to see the pattern here. Actually, I'm going to circle this. You can see the top numbers. The numerator's right here. I use a different color. Here it's negative 1. Here it's positive 1. Here it's negative 1. When the exponent's odd, you get negative 1. When the exponent's even, you get positive 1. So the next one, if I do n equals 4, I'm not even going to plug 4 in. I'm going to get positive 1 up top. That's actually a geometric sequence, which we'll talk about later. The bottom is that arithmetic sequence. Look, I have 1, 3, 5. So real easy. This is going to be 7. That's the 4th term. If I want to do the 5th term, I know I'm getting sloppy here. If I want to get the 5th term, well, this 1, this changes to negative 1. and this 7 goes up to 9. So that's my 5th term. So a lot of these, if you just get the first couple terms using the formula, then you can just see the pattern and kind of cheat, get the next terms in the sequence. Okay, probably one of the last things I'll do is this, the factorial right here. Let me erase what I just did. Give me more space. Okay, and let's just kind of come up. Definition, when you see the exclamation point, that means factorial in math language right here. So n factorial, this just means n times n minus 1 times n minus 2 times n minus 3, all the way until you get the 1. So I'll put times 1. 0 factorial, now that definition is kind of like if you raise something to the 0 exponent, that's just 1. 1 factorial is also 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1. Again, I'm trying to squeeze it in, which is 6. 4 factorial is 4 times 3 times 2 times 1, which would give me, what, 24? I'll squeeze 5 down here. This is just 5, 4, 3, 2, 1. That's all factorial means. You use a lot of this when you do probability, which you did do in Algebra 2. If you did 5 factorial, you can do 120. Now, there is a button to do this on the calculator, so you don't have to do all this. 5 times 4 times 3 times 2 times 1. Let's see here. Let's just do number 4, and then that'll be the last thing we'll do. The whole backside we'll go over tomorrow in class. All right, so let's do this. Let's find the first 5 terms of the sequence. This is our formula. So if I let n equals 1, I'm going to have 2 to the first over, which is 1 factorial. Well, 2 to the first is 2. 1 factorial is 1, so this is just 2. If I let n equal 2, I have 2 squared over 2 factorial. Well, 2 squared is 4. 2 factorial is 2 times 1, which is 2. 4 divided by 2 is 2. So we get the same term for the first 2 terms. Okay, I do n equals 3. I have 2 cubed over 3 factorial. 2 cubed is 8. 3 factorial is 3 times 2 times 1, which is 6. That reduces to 4/3. Okay, I do n equals 4. Again, you can really think it's almost kind of like mindless right here. Let's see here. N equals 4, so I have 2 to the 4th over 4 factorial. 2 to the 4th is 16. 4 factorial we got was, what, 24. This fraction reduces to, was this 2/3? You can see as we're going down the list, the numbers get smaller. Now let's just do one more. Let's go n equals 5. So when we plug this in, we have 2 to the 5th over 5 factorial. 2 to the 5th is 32. 5 factorial is 120. And then if you just use your calculator to simplify that, that simplifies to 4/15. So this right here, these are our first 5 terms. Now, we'll end with this one. You really can't see the pattern. When you have factorial, it's much harder to see the pattern. So if they give you the formula for it, you can see you really have to plug the numbers in to get all the numbers in the sequence. The previous ones, it was a lot easier to see what the next fraction or what the next number would be in the sequence. All right, so this is just kind of like a brief intro. We'll go over the backside tomorrow, but we'll spend a couple days on 9-1, and then we'll get into certain types of formulas to deal with certain types of sequences and patterns. Ciao.